Welcome to Brain Vision.
Alright guys, let's take a look at the question one. Well, question one was asking the temperature at the fat inner fur boundary, okay? So it's the lower temperature from the fat side. So we know the heat current is 50 watts, okay? And the thermal conductivity for the fat is 0.2 watts per meter times Kelvin. The surface area is just the surface area of the sphere, which is 4 pi r squared, which is 4 pi times d over 2 squared, which is 4 pi times 0.75 meters squared. The higher temperature is 31 degrees Celsius. And the length, or let's say the thickness of the fat is 4 centimeter, which is 0.04 meter. If we arrange it, we can get Tc equal to Th minus H times L over Ka, which is Tc equal to 31 degrees Celsius minus 50.0 watts times 0.04 meter divided by 0.2 watts per meter times Kelvin times 4 pi times 0.75 meters squared. It will give us 29.6 degrees Celsius. For question B, we are looking for to figure out the thickness of the air layer, which is the fur part. Okay. So due to thermal conduction, the two layers should have the same heat currents, which means H1 equal to H2. So Ka times Th minus Tc over L is equal to K prime A times Th prime minus Tc prime over L prime. And surface area is the same since it's the same sphere. So A and A cancel out. And we already figured out the temperature at the fat and inner fur boundary, which is the lower temperature at the fat part, okay? But 29.6 degrees Celsius is the higher temperature at the air layer because remember, this is the fat and fur boundary right here. Let me use a red line here. This is the fat and fur inner boundary. So at this part, the temperature is 29.6 degrees Celsius. So the lower temperature is this part for the fur, for the air layer. Okay? So if we take the deeper derivation, so we can just plug in the value for each part. We got, well, sorry, let's, if we organize, if we rearrange the equation, we'll get L prime is equal to K prime times Th prime minus Tc prime divided by K times Th minus Tc over L. And the K prime, which is the thermal conductivity for the fur, which we also consider is the thermal conductivity for the air because the fur basically touches the air. So this is K prime is equal to 0.024 watts per meter times Kelvin. Okay. So, sorry. So if we plug in the value, we get 0.024 watts per meter times Kelvin times Th prime is 29.6 degrees Celsius minus Tc prime, which is the outermost part of the bear, which is 2.7 degrees Celsius, divided by 0. Let's take a look. Was 0.2 watts per meter times Kelvin. Okay, so 0.2 watts per meter times Kelvin times 31 degrees Celsius minus 29.6 degrees Celsius over the thickness of the fat, which is 0.04 meter. and they'll give us L prime, which is the thickness of the fur, is equal to 0.091 meter, which is 9.1 centimeter. Okay, and that's the answer for the question. Thank you.